I hope you guys get something out of these recordings. When you're absent, I'm really counting on you guys to go on the website, on YouTube, on the trig review. I think I had 78 views, which is quite a bit over half the class. If you're absent, spend some time on the computer, right, so you don't get too far behind. All right. And let's graph the cosine curve. And notice that I kind of opened it up, and we're not going to graph on a circle anymore. We're going to graph the whole cosine curve. So basically what we're doing is we're putting it on a coordinate system. All right? So let's take some values here. Notice that I numbered it not by 1 on your x-axis. This is actually your theta. All right? And then this is what your y is. Okay. All right. What is the cosine of 0? Cosine of 0 is 1. Okay. So we've got that point. What is the cosine of 90? 0. Cosine of 90 is 0. Cosine of 180? Negative 1. Now, I expect you guys to have these memorized by now. Cosine of 270 is 0. And cosine of 360 is 1. Okay? So we've got these points there. Well, it's not going to be a jagged line. How about the cosine of 30 degrees? Square root of 3 over 2. And that's somewhere up in here. Cosine of 45? Square root of 2 over 2. Cosine of 60? Okay, so about here. And this middle one's off a little bit. Well, if you start graphing all of these points and you connect them, it's going to be a smooth curve. So it's going to go like this, and down, and up to 1. And then what do you think is going to happen after 360? What's going to happen? It's going to start again. Well, that is called a period. All right. So if it goes from the y-axis, and where it starts to curve again, that same pattern, that is called a period. And so this period is 360 degrees. Okay? If it goes in the negative direction, okay, I'm just going to go up like that. All right, that's a cosine curve. Sine curve. Sine of 0? 0. Sine of 90? 1. I expect you to know this. Sine of 180? 0. Sine of 270? Negative 1. Look at the cosine curve. It is between 1 and negative 1. That's why if you try to do the inverse cosine of something greater than 1, you get an error domain. Okay? Because your cosine curve has to be between 1 and negative 1. So does the sine curve. And doing the same thing with the sine curve, you're going to find that this goes, and it looks very similar. And the period there is also 360 degrees before it starts again. And in the negative direction, okay? So we have the cosine curve in black, and we have the sine curve in green. All right? Can we stretch that? Mm-hmm. Sure. And let's stretch. So let's say we have y equals 2 cosine theta. you're going to find that it comes like this. All right, and it'll go to the left as well. Okay, so we have the sine curve, cosine curve. Now this vertical stretch, putting it in front of the function, this is called the amplitude. In trig, we don't call it a stretch. The amplitude is, but it does stretch. Okay. All right. And the period, 360 degrees. Do you think I can take and do a horizontal compression and push that in to where it's going to be up and down real quick like that? Sure. Yeah, we can. Okay, so let me show you how to do that. All right, by the way, I'm going to pause this and, well, not yet. Let's graph the cosine curve in your calculator. Go to your y equals, and we're going to plug in cosine of x. Use your x variable key, because that's also with theta as well. Cosine x, and you might want to. All right. Now, if I were to graph this, doesn't look right, does it? Okay. Did any of you guys graph it in a straight line? Yeah. Yeah. So what happens there? All right. What you have to do is go to your mode, and we graph in degrees. So you have to change your calculator to degrees. I was in radians. Okay. Then you have to go to your window, or you have to go to your zoom menu, and scroll down to Z trig. And that adjusts your window. And you enter on that. And there's your cosine curve. Okay. Now, let's go to your window now. Hit your window button. And you can see what the x-axis is, or a theta axis. I don't know why, but on my calculator it says from negative 352.5 to positive 352.5. And I don't know why it stays there. But I want to go from negative 360 to a positive 360. So I'm going to enter those values, negative 360 for the x minimum, and for the x maximum, I'm going to hit positive 360. And it just sort of widens out the screen a little bit. So it shows the entire period. It doesn't come through on the TV, but it does on my screen on my calculator. All right? Now, what if we want to graph in radians? I'll help you in just a second. Let me just do this. All right. What if we want to graph in radians? All right. And I'm going to leave that. The radians is going to look exactly like that. But the first thing I want you to do is to go to your mode, change your calculators to radians. Okay. And then if you try to graph, well, that's not what we want. It should look exactly the same. Well, what you have to do is reconfigure your window again. So go to your zoom menu and scroll down to Z trig and enter on Z trig again. Now, that first point on there, on your x-axis, instead of being 90 degrees, it's pi over 2. Instead of 180, instead of this first point here being 180, it is pi, because now we're in radians. Then 270 is 3 pi over 2, and then 2 pi. And so the period there would be 2 pi. If you go to your window, kind of do the same thing on my calculator. I'm going to go negative 2 pi on the x minimum. It'll give me a decimal, but that's all right. So a positive 2 pi. And it widens out the window again. So I did just like I had to do with the degrees. All right? That's graphing. Let me go to the next screen here. The general form, y equals a. A is a real number. A sine or cosine of b theta. All right? A is the amplitude. It's how high that cosine and sine go. All right, sine and cosine. The amplitude. What is the depth of it? Y equals cosine theta. When we graphed this, the amplitude is 1. It went from 1 to negative 1, didn't it? That's your amplitude. When we stretched it and we went y equals 2 cosine theta, the amplitude we said was 2. That's the amplitude. Because it went from a positive 2 down to a negative 2, right? Okay? The period for sine and cosine, the period for sine and cosine is 360 degrees divided by the coefficient of the angle and the absolute value of that. For instance, if we had y equals 3 sine or cosine, it doesn't matter, of 2 theta. I want to know the amplitude and the period, how often it repeats. That's what the period is, how often it repeats. We can say the amplitude on this problem is 3. The period, how often it will repeat, really that's a horizontal compression, is going to be 360 over 2, which is 180 degrees. So it's going to repeat every 180 degrees. We've kind of shoved it in kind of like an accordion. On your calculator, am I in radians? I think I am in radians. So I'm going to go back to degrees because we're talking about degrees. I'm going to go to my y equals and put in 3 sine 2 theta. All right. I have to go to my zoom, go back to Z trig, because I went from radians to degrees. All right. And you can see it stretched up to 3, and it's it repeats every 180 degrees now, instead of 360. By the way, if you're in radians, the period would be 2 pi over b. Okay? Amplitude and period. We can also shift these up or down. If I hit, this is for sine and cosine, y equals sine theta minus 30 degrees. It is moved 30 degrees to the, which way? To the right. It is moved 30 degrees to the right, opposite, if it's in that parenthesis. 30 degrees to the right. This is called a shift, horizontal shift, but we call this in trig a phase shift. So there's a phase shift 30 degrees to the right. Do you think we can take that curve and move it up 2 units? What do you do? Plus 2. Okay. That moves it up 2 units. How do we do the vertical stretch, which is called the amplitude? Well, maybe put a 5 here, or whatever. Okay? So in this problem I just wrote, describe the transformation. Amplitude is 5, or vertical stretch by 5. Phase shift 30 degrees to the right, and a vertical shift up 2 units. That's sine and cosine. You have a little bit of graphics to do, not much. If you don't have a calculator, I'd really strongly suggest, and you guys going into calculus next year, if you don't own one, I know they're expensive, but you may be able to go on, well, I'm not a fan of eBay, but you may be able to go on Amazon and pick up some deals. If not new, maybe a used one. Okay, but you should have a graphing calculator at this point. All right. So we talked about sine and cosine, what happens with tangent. Graph the tangent curve. I'm in, my calculator's in degrees. So y equals tan theta or tan x.
Oh, that's pretty.
Now, I don't know why, but when I graphed this first hour, I showed asymptotes. Was I in? Yeah, I was in degrees, wasn't I? And so this would be 90 degrees. What is the tangent of 90 degrees? Undefined. And so we have a vertical asymptote at 90, 180, negative 90, or at 90 and 270, sorry. And then at negative 90 and negative 270. Those are asymptotes. Even though they're not showing on my calculator, they may or may not be showing on yours. And so we have these S-shaped curve in here. All right, that's what the tangent curve looks like. In tangent, or cotangent, there is no amplitude. Remember your sine curve was bounded by 1 and negative 1? Whatever that amplitude was, if it was 2, it was bounded by 2 and negative 2. Tangent is not bounded by anything. It goes up to infinity, down to infinity. No amplitude for tangent or cotangent. The period, how often do you think this repeats? Not 360, every 180. And so to find the period, it is 180 divided by the absolute value of b. Or if we're in radians, pi over the absolute value of b. Here's a question. Y equals 3 sine of 4 theta. What is the amplitude and period? Amplitude is 3. Very easy. The period, 360 over 4. 90 degrees is the period. Y equals 5 tangent of 3 theta. What is the amplitude? None. What is the period? 180 over 3, or 60 degrees. If we're in radians, it is pi over 3. Repeats every pi over 3, which is 60 degrees. Okay. If the bottom one here with a sine of 4 theta, it would be 2 pi over 4, which is pi over 2, which is the same as 90 degrees. So if you're in radians, it's that. If you're in degrees, it's 360. Okay? Amplitude, period, some graphing. Make sure you know how to work with your calculator a little bit. All right? We don't have a lot of time in class to work, but you have some. Do the graphing problems. Oh yeah, homework. It's on page 864 and 865. 12 to 46 even. There's not a lot of graphing. You don't have to worry about it. The story problems will be some graphing. Make sure the story problems you are in radians. Right? You'll notice by the pi there. And problem 49 through 57 all. And the story problems, there's actually only 2. And once you graph it, they just ask you questions about it. 49 through 57 all.